Welcome to the video on drawing subshells. You need to be able to draw the subshells for any element up to calcium. Okay, you don't have to do the really big ones. So let's just review what are the subshells. First we have S, which stands for sharp. Then we have P, which stands for principal. Then we have D, which stands for diffuse. Oops, two F's in diffuse. And F stands for fundamental. That's just what these letters stand for. Now let's talk about what shapes they actually have. S is actually a sphere shape. So it's going to look like this. In 3 dimensions, I have a model. Here is 2 versions of an S. So we have a small s. There we go. So we have a smaller s here and a bigger s there. And the s's come in different sizes depending on what energy level you're in. We're going to talk about that in a little bit. P are dumbbell shape. Now remember from the last video I told you that there are 3 orbitals in P. There's only 1 orbital in S. The orbitals are basically like an axis. A sphere doesn't have different axes. It looks the same all the way around. But if you have a dumbbell, I could draw it like this. I could draw it like this. Or if I was capable, I could draw it coming out of the board to you and back behind the board. And so then I'd be on the axes X, Y, and Z. And so that is 3 orbitals. 1 for each axis. Let me show you an example of that in 3 dimensions. So here is your 3p orbitals. So we have the one going in the x-axis, the one going in the y-axis, and the one going in the z-axis. And the y one, you can turn it, you can see where it goes forward and backward like that. Okay, so these are the 3 orbitals, and collectively this makes up the p subshell. Then we have the D subshell, which, as you saw in the last video, has 5 orbitals. These are, it gets more and more complicated as you go up the list. So these are cloverleaf shapes, and there are 5 of them. So we have them pointing in 5 different directions. We have them going up like this, out like this, turned a little bit from that one, and kind of cat-a-corner there. And then the last one's not even a clover leaf, it's just a dumbbell with a ring attached to it. But the point is that there are 5 of them, and all together, this makes 1 D subshell. 5 orbitals, 1 subshell. The F is 7 orbitals, and those orbitals are like double clover leaves. I don't even have a model to show you that. In class, next class, I will show you a picture of it that I have on a slide. So how do I draw these? Well, if you were going to draw an S, you would just draw a circle. Okay, you don't have to do it in 3 dimensions. If you were going to draw a P, and if this was the nucleus in the middle here, the P would go out in that direction. That was 1 orbital in P. You have to do all 3 axes. So there's the second axis. And then the third one's supposed to be coming out and going back behind like that. So that would be an example of drawing an S and a P. If you need to draw another S, you can draw another S around that. You can draw another P around that. In all 3 axes. And you could draw another S around that, and so on and so forth. All of the elements up to calcium contain only S's and P's. I do not expect you to be able to draw D's, and I certainly don't expect you to draw F's. But you have to be able to draw S's and P's like that. Thank you.